All right, now we're going deeper into the harder questions of practice test 2, part 2 of the math, page 3 of 3. Again, these are supposed to be slicker questions. Let's see how slick these guys can be. Remember, all the tougher questions, the harder questions for students are really easy stuff mashed up into one question. It could be 3 easy parts, 4 easy parts, all mashed up in the question that a lot of students get locked up on. So let's see how rusty we are. Here they're telling us the triangle XYZ is similar. Remember, that's the key word, is similar, which means the angle measurements are going to be exactly the same for corresponding angles, but the length measurements are going to be different. Again, the angles will be exactly the same, but the length measurements will be different, but they will be proportional. So similar, all equal angles, proportional sides. All right, here I'm going to draw, since they didn't give us the image, I'm going to draw XYZ, XYZ, and I'll do this one in green. It could be bigger, it could be smaller, but again, they're proportional. Triangle RST. In the same direction that I wrote my XYZ, I'm going to do my RST. So X goes with R, Y goes with S, Z goes with T. The measure of angle Z is 20 degrees. So let me write that 20. That 20 goes in here. What else is going to be 20 degrees? Angle T. Remember, when they're similar, this angle will be the same as this angle measurement, because they're in proportion to one another, the length measurements, but the angles are exactly the same. So far we got that. Angle X and angle R are exactly the same also. Then they give us extra information where they tell us that 2 times XY is equal to RS. So twice XY. So let's say XY equals 5, right? Let's say XY equals 5. So what is RS going to be? It's going to be 2 times XY, which would be 10. So there's a 1-to-2 proportion with the corresponding length measurements. Here, I'll give you another example. If they told us that YZ is, I'm making up numbers. If they told us YZ is 4, then ST must be 2XY. It's going to be 8. And if they told us, making up numbers again, if they told us that XZ is, I don't know, let's say it's 10, then what does RT have to be? 2 times XZ, which would be 20. So it's a 1-to-2 ratio, 1-to-2 ratio all the way around. But I just made up those other numbers, but we do know for a fact they give us 5, so RS would have to be 10. Okay, so what is the measure of angle T? Oh, angle T is just 20 degrees. Yeah, that's pretty much it. That's the answer to our question. Boop, 20 degrees. So they're trying to get you confused with this sucker right here. But the confusion isn't what I just circled. Is to verify, to tell you that they are similar, because when you have similar triangles, you're dealing with proportional sides. So 5 isn't proportional, 10 is a 1-to-2 ratio. But the whole deal is that the angle measurements are equal. Here, check this out. If I said angle Y is a right angle, what does angle S have to be? A right angle. So what would angle X and R have to be? X and R would have to be 70 and 70. So they could be congruent triangles if the side measurements were both 5 and 5 for the short leg, but it's not. It's a 1-to-2 ratio, so they are similar triangles with the same angle measurements. All right, question number 19. They're showing you y equals 6x plus 18. That is a slope-intercept formula. Then we go into the question. One of the equations in the system of the 2 linear equations is given. All right, that's what they gave us here. But then they say the system has no solution. If it has no solutions, that means that the 2 lines are parallel. Now, they didn't give us the second line. They're telling us that one of the answers, one of these guys, has to be the formula that is parallel to this guy right here. So I'm going to slide this here. Y equals 6x plus 18. So if I'm going to find the formula A, B, C, or D that is parallel to it, that means if they're parallel, they have to have the same slopes, but different y-intercepts. Got it? That's all you need. So one of these has to have the same slopes with different y-intercepts. So what would it be? It would be y equals the same slope, and it could be any y-intercept except for 18. It cannot be the same as 18. Otherwise, they would have multiple solutions or unlimited solutions or infinitely many solutions. So we're looking for no solution. That means they're parallel. They never touch. If they do touch, those are solutions. They do not touch. That means they're parallel. They never touch each other. All right, here we go. So let's take a look at our answers from the bottom up. If I'm going to solve for y for answer choice D, I'm going to get y equals a positive 12x plus 18. 18. Does that equal 6x? No, so D is out. The same thing is going to happen with this guy. That'll be y equals a positive 12x. That does not equal 6x. Goodbye. Now we go into B and C. It's got to be one of those. So here, this one's going to be y equals, add 6x to both sides, 6x plus 22. Is 22 different than 18? Yep, I believe this is our answer, but let's verify A. Y equals a positive 6x. Yes, the same slope, but I have a plus 18, which is exactly the same as this guy, and it cannot be the answer. If they are exactly the same, they're the exact same lines, which means I have infinitely many solutions. They touch each other all over the place, but we're looking for no solutions. They must be parallel, so B is the best answer. Question number 20. What is the area in square centimeters of a rectangle? All right, give me that rectangle. With the length of 34 and a width of 29 centimeters. All right, so 34 and 29, they're both centimeters. What is the area? What is that? Length times width, so it's 34 times 29. I use my calculator. 34 times 29 equals 986 is the answer to this question. Question number 21. The solution to the given system of equations is xy. What is the value of x minus y? All right, so the first formula that's shown us is y equals 4x plus 1. The second one is 4 times y equals 15x minus 8. Look, they're showing me that y, right? Equals 4x minus 1. I got that y right in there, so let me just rewrite it. So 4 times, I'm going to write, what am I going to write? 4x plus 1. So I'm taking a y, 4x plus 1, I'm sticking it right in there, and there she is. And what does all that equal? It equals 15x minus 8. So now all we're going to do is solve for what? Solve for x. Let's get our x done. Actually, you know what? Let me slide this to the side. So I'm going to write right below that. All right, there we go. So let's solve. What's 4 times 4x? It's going to be 16x. 4 times 1 is a positive 4 equals 15x minus 8. All right, let's solve for x. I'm going to subtract 15x from both sides. That's going to leave me with x, right? And then I'm going to subtract 4 from both sides, and that's going to give me a negative 12. So my x equals a negative 12, and then I have to solve for y. So now I can take this negative 12 and solve for y. I can stick it right back, stick that x right back into that equation, which is showing me y equals. All right, let's go ahead and solve. So y now equals, I'll do it in green, y equals 4 times a negative 12 plus, what is that, a 1? Plus 1. All right, 4 times a negative 12 is going to be a negative 48 plus 1 equals a negative 47. That negative 47 is our y value. So that's going to be minus 12 plus, or actually subtracting, let me erase this. There we go. So it's going to be a negative 12 minus, and what's my y value? A negative 47. So what is a negative 12 minus a negative 47 equal to? Remember, we have to change the signs and add. So our answer is going to be 7 minus 2 is 5. 4 minus 1 is 3. So your answer is 35 for this particular question. Question number, you get it? They're just testing mechanics. It ain't that hard. So if you kind of get lost in this, just back it up and rewatch it, and you'll get it. It's not hard. Remember, first we solved for x or y. I decided I'm going to solve for x by taking all of this sucker and plugging it into that y. Then you distribute, solve, you get x equals a negative 12. Then you got your x equals negative 12. We're going to solve for y. We're going to take that negative 12 and stick it right in there. So we get 4 times a negative 12, which is a negative 48, plus 1 equals a negative 47, and that's our y value. So there we go. We got our y, we got our 12, and then we subtract negatives. We add the signs. Bang, we get 35. 22. How many distinct real solutions? All right, here we go. Distinct real solutions. A few questions ago, and also plus in a previous practice test, they go over this. Whenever you see they're asking for how many distinct real solutions, or they tell you there are 2 real solutions, or they tell you there's 1 real solution. So here's the variety. They can say, oh, there's 2 solutions. There's 1 solution. Or they say there is no solution. These are code words. All right, code words within the question in which they're bringing up what's called the discriminant. Which is, remember your quadratic formula, within the radical, you have some numbers that is b squared minus 4ac. your discriminant. Now, in this question, they're asking how many distinct real solutions does the given equation have? So our answer, whatever answer we get, we're either going to get 2 real solutions, 1 real solution, or no real solutions. But how do we figure this out? Check this out. I'm going to take our discriminant. Let me erase the word discriminant from here. I'm going to take our discriminant, and it's going to go here, right, for the first one, or the second one, or the third one. So if we took our b squared minus 4ac and we got it to, if it's going to be 2 real solutions, then that formula, b squared minus 4ac, if it equals, check this out, I'm going to put a big fat equals in red. If it equals 0, we got 1 real solution. If it is greater than 0, we got 2 real solutions. If it is less than 0, we have no solutions. So that's what we're looking for. Is it going to be greater than 0? Is it going to be equal to 0? Or is it going to be less than 0? Got it? All right. Now, let's take the equation. What is our A value? Our A value is 5. What's our B value is 10. Our C value is 16. All right, let's plug these suckers in. So our B is 10 squared. So I'm going to stick the 10 in there. Minus 4 times, what is our A value and our C value? Our A value is a 5, and our C value is a 16. All right, it's either going to be greater than 0, when we solve it's going to be greater than 0, equal to 0, less than 0. All right, let's solve. What's 10 squared equal to? 100. What's a negative 4 times 5? That's a negative 20. A negative 20 times 16 is going to be a negative 320. If I solve that, that's going to be equal to a negative 220, which is certainly less than 0. So if it's less than 0, that means there's what? No solution. So 0, no solutions. Ooh, ooh, isn't that awesome? All right, question number, you'll see answer choice C. Answer choice C does not deal with quadratics. Answer choice C deals with linear formulas in the SATs and ACTs. Now this would deal with quadratic, and this would deal with quadratic, and this one deals with quadratic, right? When you have 0 solutions or no real solutions, remember the entire formula must be equal to, less than 0. When you have exactly 2, that would be greater than 0. When you have exactly 1, that would be equal to 0. Ta-da! Question number 23. Data analysis, we're dealing with ratios. Ooh, big numbers. A certain park has an area of 11,863,808 square yards. And then they're asking, what is the area in square miles of this park? Okay, so we're going from yards to miles. All right, so we got 11 million square yards. So we're going to convert it to miles, which means it's going to be a much smaller number than $11 million. $11 million square yards. But let's go into a conversion. So let me write the 11,863,808, and that is yards squared, right? So what is, let's go with the square root of that. So if you took your 11, and hopefully you got your calculator. I have a dollar store calculator, and it kind of works. It would work with this. I might have to shorten up the numbers, but no less, it's still going to give me the right answer. 11,863,808. If I got the square root of that, it's going to give me, whoops, I squared it, 11,863,808 square root. It gives me, right, if I square root it, it's going to give me 3444.3, I'll round it to 3.39. Now look at your answer choices. This is bait. They want you to bite on that, but all we did was get the square root of the total number of yards. So that's going to equal 3,444 yards. That's not the answer to our question, so C cannot be the answer. Now, we got the conversion. They want it in miles. So if we're going to convert it to miles, I'll use, I don't know, labels. So what would that be in miles? I don't know. But I do know that 1 mile is the same as 1760 yards, right? So now I want to figure out what the miles are, or your x. So you could just cross multiply. So that would give you 1760. X is equal to 3444. Some of you guys are already seeing through this. So x is going to equal 3444 divided by 1760, which is see, I want to shorthand this so badly, which is approximately what? Which is approximately 2. So I can write my 2 there. So how many square miles is this sucker going to be? I'm not even going to do the calculator math, because now that I got that, square miles, I'll just have to square it. Miles squared. So that means it's going to be 2 squared, which is equal to 4. Which answer is closest to 4? Bang, and that's your answer. But in case you want to do 3444 divided by 1760 equals, that'd be 1.95. Now, if I squared it, what is 1.95 times 1.95? And that will be 3.81, which is still close to 3.83. I hate being too specific on this because you can see right through what they're trying to do. They're trying to, you have a lot of students who are trying to be very correct and very exact, and they'll get nailed in this question because they'll be off by like, I don't know, like 10 or off by 6. And they'll be like, oh man, I didn't do it right. No. Remember, you can ballpark this. You don't have to be exact and specific on this. Try this out by ballparking your miles. All right, next, 24. I see these equations and answer choices. I am very familiar with this because these are equations of circles. I'll go from the bottom up just to quickly explain what these guys are. So anything on the right-hand side of the equation deals with the radius, but for each one of these, we have to square root these. So now we have our answers. The square root of 16 is 4 for each one of these. So they're showing us that the radius for each of these circle formulas happens to be 4. Now, the center coordinates are on the left-hand side of the equation. So the center coordinates, your x and y coordinates for the center, see how this is x minus 8? Set it to equal 0. If you set it to equal 0, then x equals a positive 8, and y would equal a positive 8 when you set y minus 8 to equal 0. This guy will also be a positive 8, and this guy is going to be a positive 4. This guy is going to be x equals 4, and this one's going to be y equals 9. And this one is just x squared, so that means x equals 0, and y equals 9. So I'm just interpreting what the answer choices are. They are circles. Each one, they're giving you the center coordinates, and they're also giving you the radius. Let's go into the question. Once you understand that, you realize that these questions are not that hard. But for most students, they're going to get nailed. All right, which of the following equations represents a circle? Yep, that's what they do. Recognize all formulas as circle formulas. Represents a circle in xy plane that intersects the y-axis at exactly 1 point. So it's got to touch the y-axis at only 1 point. So let me draw this sucker right here. For D, I'll use red. So if x is 0 for my standard coordinate, I'll go at 0, but my y is a positive 9. Let's say this is the positive 9. That's the center of my circle with the radius of 4. 1, 2, 3, 4, 1, 2, 3, 4. So that means the side of my circle would be here, the other side would be here, and I go downstairs 4, and then upstairs 4. Bang. So it goes through, oh, check it out, but it goes through my y-intercept. How many times? It touches the y-intercept twice. It touches it here and here. It says exactly 1 point, so D cannot work. All right, let's go black with the next answer choice, C. So I have a radius of 4, but my x-coordinate is a positive 4. So that means I'm going to go 1, 2, 3, 4, but I have to go upstairs 9. So there's the center of my circle. Now, to the right-hand side of my circle, 1, 2, 3, 4, that'll be my right side. My left side is going to be 1, 2, 3, 4. My north side, 1, 2, 3, 4. And my south side, 1, 2, 3, 4. If I connect this, how many times do I touch the y-axis? 1 time. This must be the answer to my question. Let's try yellow for B. I think you guys got this. X equals 8, so that means I'd have to go all the way out here. And then y equals 4. So if I go to my y value is 4, it'll be right about there. Now with a radius of 4, my circle is going to be like this. Does it even touch the y-axis? No, not at all. Actually, let me fix that. Y equals 4. So does it? It would be something like this. It's not really drawn correctly, but it touches the x-axis at 1 point, but it doesn't touch the y-axis, so it's out. I kind of messed up the circle. Let me draw it better. It'd be something like this. It's kind of skewed. That's better. And if I did, Answer choice A, that's 8 and 8. X equals 8, y equals 8. So it'd be all the way up here to the center of my circle, but the radius would go something like this. And that's not even touching the x or y coordinates, so therefore C is the best answer. Question number 25. All right, here we go to triangles again. Are you guys seeing a pattern to these when you guys are practicing? They love asking the same crap over and over again. In triangle ABC, so I'm going to draw ABC, a triangle. And I'll draw another triangle. Doesn't have to be exactly the same. I don't know if they're congruent, if they're similar. I'm just drawing them. My ABC, I'm going to write them in the same order, A, B, C. And my D, E, F, same order, D, E to the F. Because if they are corresponding angles, they'll be related to similar triangles or congruent triangles. Either way, it's the same. Continue following the recipe. Angles B and E each have 27 degrees. So my B is 27 degrees, my E is 27 degrees. See how it works? Okay. Oh, but Mr. Ober, you draw like 90 degree triangles. No, it's okay. Just draw triangles. I like drawing 90 degree triangles because a lot of the questions deal with 90 degrees or right triangles. And then they tell us that C and F each have a measure of 41 degrees. So 41 for C, and F is also 41 degrees. So far, we know that these two triangles are going to be congruent or they'll be similar. Oh, just for fun, what is going to be the measurement of the last angle? So the last angle, remember we have 180 degrees in any triangle. What's 27 plus 41? That's going to be 68. So if I subtracted 68, what do I have left over? That would be 2, 7, 112. Is that right? Yeah, 112 degrees. So that's 112 and 112. Right now, if these two triangles are congruent, they would have to share the same corresponding size. So BC, if it equaled 3, then EF would have to equal 3. That means that these guys would be congruent. Now, AB, if I said it equals 4, that means that DE would have to equal 4. And if they're congruent, let's say this is 5, then this would have to equal 5. They're exactly twin-like, so they would be what? Congruent. Well, what if they were similar? If they're similar, we'd have the same situation with the side measurements not shown, but the angle measurements would be exactly the same, just like congruent. So similar triangles do the same thing. They have the same angle, corresponding angle measurements. But if we said that BC is 3 and we said that EF is 6, then we notice the short legs have a 1-to-2 ratio. If I said AB is 4, then DE would have to have a 1-to-2 ratio. If I said AC is 5, then DF would have to have a 1-to-2 ratio. That would make them similar. All right, let me get rid of the side measurements. I just want to include the information about congruent and similar. What's the actual question asking us? It's asking which additional piece of information is sufficient to determine whether triangle ABC is congruent to triangle DEF. Well, we already figured out the angle measurements are all the same, right? So what else is going to be sufficient enough to determine that ABC is congruent to DEF? Go with your answers from the bottom up. Could it be no additional information is necessary? No, absolutely not, because they can be either congruent or similar. We need to know that they are congruent. What about C? The lengths of sides BC and EF. If BC is 4 and EF is 4, if BC is 4 and EF is 4, we're done. Then we know they're definitely congruent. Got it? Now, let's verify. I'll circle C. What about the length of AB? If we only knew the length of AB and nothing else, is that going to be enough to figure out if they are congruent? No. What about A, the measurement of angle A? No, we figured out it's 112 and 112. They're still going to be either congruent or similar. The only answer that would work, if they told us that BC is 4 and EF is 4, definitely congruent. But what if they said BC is 4 and EF is 2? It's a 2-to-1 ratio, then they're similar. They're not congruent. But definitely C is your answer if they told us that both measurements are 4. Done. Question 26. All right, this has a lot of yada information. We're going to have to compare the data sets. And notice what they're showing you, right? I'm going to open up. Look, we have to come up with an answer, A, B, C, or D. It's numbers, they're not formulas. We see the bar graphs. Now notice, I'm going to underline in green the clue that you have to know that you're dealing with a dirty question, number 26. Two data sets of 23 integers are each summarized in a histogram shown. Boom. You see the word histograms? You're probably going to pass on this question. It's not going to be hard. It's clunky, but not hard. Histograms. Clunky, not hard. Ready? Histograms. Clunky. That means skip and come back because it's going to suck up your time. It's like going over a speed bump. Now, for each what? Histogram, the first interval represents a frequency of integers greater than or equal to 10. So they're saying this interval right here, it's going to represent numbers that are equal to or greater than 10, but check this out, less than 20. So if I go all the way up to this end, it's going to be less than 20. So that means our numbers can go from 10 to, let's say, 19.9. Got it? Now the new interval from here to here will represent 20 to what? 29.9, not all the way to 30. It looks like it goes all the way to 30. No, that the other interval would begin with 30 and then end with 39.9. Get it? So when you have these type of questions, skip it for now and then go to the next question. This is the last one. So I assure you that this is going to be easier if you know your triangle rules. A right triangle has legs with lengths of 24 and 21 centimeters. Let's draw it. A right triangle. I'm not drawing it accurately. It has a length of 21 and 24. All right, cool. For the right triangle, we're going to be dealing with Pythag more than likely, right? Or we could be dealing with similar triangles or concurrent triangles like we saw in questions before. Let's go into the rest of the question. If the length of the triangle's hypotenuse, so your hypotenuse is the longest side. If the length of the hypotenuse in centimeters, now everything's in centimeters, right? We got centimeters, centimeters, and centimeters. The hypotenuse can be written in the form of 3 radical D, where D is an integer. What is an integer? It's a whole number, right? It's got to be a whole number. What is the value of D? Okay, once you see this, what did I say we do with right triangles? You're dealing with Pythag. So what is Pythag? Pythag is using the two shortest side measurements, which is going to be a squared plus b squared, and it must equal c squared, or our hypotenuse. So what if we took 21 squared plus 24 squared? It's got to equal c squared. So here's where you use your trusty calculator, or you could do it by hand. 21 times 21 is going to equal 441. Plus, what is 24 times 24? That is going to equal 576. And that must equal c squared. Now we actually add 576 plus 441. That's going to equal 1017. Stop. If you use a calculator to figure out the square root of both sides, right, that's going to give you c equals radical 1017. But if you try to solve it that way, they got you. They own you. So what do you have to do? We're going to have to tree this sucker. Now notice that they gave us the 3 at the beginning, right? So I know that there's going to be a factor of 3. It's got to be a pair of 3's inside that radical. How many times does 3 go into 10? 3 times, carry the 1. How many times does 3 go into 11? 3 times, carry the 2. How many times does 3 go into 27? 9. Can we still tree this out? Yep, by using another 3. Woo! Now I got a pair of 3's, which means it's going to go around the outside the house. So 3 times, how many times does 3 go into 339? 3 goes into 3 one time, 3 goes into another 3 one time, 3 goes into 9 3 times. So that means that your answer is going to be 3 radical 1, 1, 3. So what does D equal? D equals 1, 1, 3. And that's it. Ding dong, the witch is dead. All right, let's go back to the previous question and let's break this down. I hate these questions because it's really conceptual. The most important part is the clunky part. All right, revisit. The clunky part, we're dealing with the intervals. The intervals, the first group of intervals, which is, I'll do this in blue, from 10 all the way to the red line, represents 10 all the way to 19.9. The other interval represents 20 all the way to 29.9. The next interval begins here with 30 all the way until 39.9. You guys got that? That's really all it means. So let me clear some of this out so it's less messy. Stupid question. Okay. Now we go into the rest of the question since we understand what the two data sets are showing us as far as intervals. The second interval represents a frequency of integers greater than or equal to 20 but less than 30, and so on, just like what we had talked about upstairs. Now the stupid question. What is the smallest possible difference between the mean of data set A and the mean of data set B? What is the smallest difference between the averages? Hey. All right, bear with me. We're going to do this. Okay. For the first group, for the first bar, what's the frequency of the first bar, right? It's 1, 2, 3. So it is a frequency of 3 times. There are going to be 3 numbers between 20 and 29.9. The frequency of the second, the second interval is going to be 4, right? Is that 4 right there? It matches up with 4. That's all we're doing. The next one is going to be what? 7. And the next one is going to be 9. All right, cool. Let's go to the second bar graph. So the first one is going to be 3. The second one's going to be 4. The second one goes up to 7. The other one goes up to 9. We cool? Okay. And they're asking, what is the smallest possible difference between the mean of dataset A and the mean of dataset B? But notice the pattern is 3, 4, 7, 9, 3, 4, 7, 9. The first one begins with 20 through 30. And this one begins with 10 through 20. All right. I could take one of them. All right, so notice, gosh, I'm trying to explain this so you get it, because there's not a lot of work to be done. All right, if we were to take a look at those two, just those two, we're dealing with 3 numbers, somewhere between 20 and 30. Let's do the blue one first. What is the smallest number that interval can have? It's 20. So therefore, what is 3 times 20 equal to? It would be equal to 60. Right? Because we're using the smallest possible number that it can be. We cool? So that means 3 times 20. Well, let's assume there are 3 numbers 20s in that range between 20 and 29.9. The lowest number is going to be 20, so 3 times 20 is 60. Now let's go to the red side. What is the highest number that you can use, right? So we got 10 all the way up to 19.9. So let's do 3 times 19.9. 3 times 19.9. I should have just used 3. No, you know what? Instead of getting confused, let's just use 3 times 19. So 3 times 19 is what? It's going to equal 7, 2, 5. Yeah, 57. We cool? All right, so if we took that, this is so stupid. All right, so we total up 57. The first one is 60. All right, so if we get the average, we use 3 numbers. What's 60 divided by 3 equal to? That's going to equal 20. And then this is so stupid. What is 57? Because we use 3 numbers, right? We use 3 numbers. What's 57 divided by 3? That is going to equal what? 19. So then, what's the big difference? What's 20 minus 19 equal to? It just equals 1. That'd be the difference, the smallest difference in your average between dataset A and dataset B. But Mr. Alberto, you ignored the 4, the 7, the 9. Yeah, I did, because you're still going to get the same difference of 1. All right, at this point, if you're done, you understood it, terrific. Thank you for going through this homework page. You've understood the toughest questions for Test 2, Part 2 of the SAT Digital Practice Test. You're going to notice that the first third of the questions are easy, the middle third and medium level, they get kind of twisted, and then they seriously get twisted in conceptual means in the last third. So if you're done with this, great. For those who did not understand 26, that you want an extra explanation, stay tuned. The rest of you guys, fold out. You are DUN done. There's nothing more to do. You might want to rewind and understand this, but I gave you the shortcut method, so I don't want you wasting time. But for those of you who don't understand, let's go backwards. I'm going to clear all this stuff. You see the question from scratch? You see the clue words are histograms. Whenever you see the word histograms, you know you can skip this and come back to it. Now you come back to this. We understand what are those? The intervals. So the smallest number in this group of the first bar that I just marked, the smallest number we can use is 20, and the highest number we can use is 29.9 up to this point right there. Cool? The next bar is going to be 30 to 39.9. The next bar would be 40 to 49.9. And then I'll do the next bar. What is it going to be? The lowest number would be 50 all the way up to, you can't touch 60, it'll be 59.9. We cool? Just basic ding-dong stuff about the numbers that sit within the histograms and their intervals. Okay, the same will apply to the other data set B bar graph. Are we cool so far? All right, so I'm going to change the blue in this guy. Now, what's a frequency? We said it's a frequency of 3. That one is 4. Remember, it matches up. What does that match up? Matches up with 7, and this guy matches up with 9. We cool? And we said the second was the same thing. It's going to be 3, 4, 7, and 9. Now, I only chose the first bar to figure out the average. We're going to do all of them because that's what the average student would do. You'll do it today for all of them, but in the test, you're not going to do it for all of them. You're going to learn a good lesson of not wasting time. So if we take the lowest number, which is 20, what's 3 times 20? We got 60. Then we take the lowest number, 30. 4 times 30 is 120. Then we take the next lowest number, which is 40. 7 times 40 is going to be 280. And then we have 9 times 50, which is going to be 450. Now we add up what is 450 plus 280 plus 120 plus 60 will equal 910. They said there are 23 integers. If we divide it by 23, what is that answer going to be? 39.56. Cool. I didn't write all the numbers. I just rounded to 39.56. Let's do the second group. What's the lowest number we can use? 10. What's 3 times 10? That's going to be 30. What's the lowest number we can use here? 20. No, scratch that. We got to use the biggest number. What's the biggest number we can use? Will be not 20, it will be 19. So what's 3 times 19? 3 times 19 is going to be 57. What's the biggest number we can use here? It's going to be 29.9 for the second interval. Remember, we can't use the 30. That would be for the next side. So what's 4 times, instead of 29.9, what is 4 times 29? 4 times 29 equals 116. All right, what's 7 times what? 39.9, but we're just going to use 39. What's 7 times 39? 7 times 39 equals 273. Dear Lord. All right, what is 9 times? What's the biggest number that we can use? It would be 49.9, but we're going to use 49. So what's 9 times 49? That equals 441. All right, so now we add them all up. What's 441 plus 273 plus 116, oh my goodness, plus 57 equals 887. Divided by what? 23 integers. So if we divide it by the 23 integers, let's do it. 887 divided by 23 equals, oh, check that out. It equals 38.56. So if I took my original number, 39.56, what is the difference between the averages? It is 1.0, and that's why it's your answer. But did we have to do all that work? No. All we need to do, and I'll highlight it, all we had to do is focus on one bar. And that's it. 60 divided by 3. Here, I'll show you. 60 divided by 3 numbers equals 20. If we do the other side, what is 57 divided by 3? 3 goes into 5 one time. We got the 2. 3 goes into 27, 19. So we take our 20, right? We subtract 19 from it. What is 20 minus 19? And then you say, Mama, Mr. Alberto, he's got skills to pay the bills. What is your answer? All right, ladies and gentlemen, peace out. Go do your practice. If you need any help, 786-877-7231. Give me a call.